Hi, this is Punitha. I'm here with my teammate Sai Bharath to present AI-based mental health chat and mood tracking service. And here's what we will discuss. Our goal was to design a chatbot that not only responds to queries but also understands users' emotions through machine learning. The system is accessible via a web interface and API endpoints, ensuring ease of use and integration. We used SQLi to reliably manage chat history and proto-buffers for efficient structured data storage. For deployment, we leveraged Google Kubernetes Engine (GKE), enabling scalability and reliable operation in distributed environments. Finally, we implemented robust logging to monitor performance and track errors seamlessly. Our project uses Flask as the API gateway, ensuring seamless interaction between users and the backend. SQLite manages user credentials and chat histories, while Protobuffer optimizes the storage and retrieval of serialized chat data for faster performance. The system is containerized and deployed on Google Kubernetes Engine, ensuring scalability and high availability. Minayo handles ML model storage, keeping them accessible and manageable within the cluster. And key Python libraries like scikit, learn, TensorFlow, and Flask were instrumental in building the chatbot and machine learning components. We deployed the application on an E2 medium GKE cluster for an ideal balance of performance and cost. A load balancer distributes incoming requests evenly, enhancing performance and preventing overloads. Coming to the architecture, the interaction starts when a user engages with the chatbot through the Flask based web interface, which handles requests like login, registration, and chat messages. Inputs are processed here and sent to GK for further analysis. SQLite manages user credentials and chat histories, ensuring persistence and smooth interaction with the Flask app. Within GK, containerized services classify messages into two streams: general queries and mood analysis. For general queries, the chatbot uses intent and BlenderBot components to generate responses. If mood analysis is required, the system tokenizes the messages, identifies the keywords, and uses a model stored in Minayo to predict the user's emotional state. Minayo facilitates a seamless retrieval of machine learning model while protobuffers efficiently serialize and store chat history for fast data transfer. Once processed, responses are returned to the user through the Flask app. Uh, if the user chooses to save the chat, it's serialized and stored, completing the interaction loop. The user interaction interacts with the system through the web interface, performing key actions like logging in, registering, typing messages, and managing chat history. This interaction is routed through the Flask API gateway, which directs requests to the appropriate backend service. Login requests are verified against the SQLite database, while chat messages are forwarded to the GKE chatbot. Within GKE, the system's core logic classifies user messages into general queries or mood analysis and generates responses accordingly. SQLite ensures reliable storage of user credentials and chat histories, enabling persistence and easy retrieval of previous conversations. Proto buffers optimize the serialization of chat data, ensuring efficient communication and storage across the components. My teammate Bharat will explain the debugging and texting.
To ensure a robust system, we utilized various tools and techniques during development and testing. Flash logs monitored real time API activity and helped detect errors, while kubectl logs on GK provided insights into containerized applications, identifying issues like memory leaks or crashes. We used curl to test API endpoints, ensuring correct responses and debugging HTTP related issues. JavaScript's debugging ensured smooth client side interactions and monitored network requests effectively. Unit tests validated API endpoints, ensuring they perform well under normal and edge case conditions. Load testing simulated multiple users to evaluate scalability, verifying the system could handle peak loads without crashes or high latency. For model evaluation, datasets were used to test mood detection and intent classification accuracy. Model parameters were fine tuned based on results for better performance. We identified and resolved bottlenecks, optimizing SQLite queries to enhance database response times and refining API logic and GKE resource allocation to reduce delays and improve overall efficiency. Now let's look at demo. This is our web page. It has username, password fields, and we can either do login or sign up. Let's do a test. Now let's log in. Try to chat with the chatbot. Let's say hi, and let's say I am happy and excited today. And now it will go to chatbot model, and if at all we type state analyze me or how am I, it is going to go to mood detection model, and we get the type of mood which we are in. And let's try and see in which state we are, and it says we are normal. Now let's try to save the chat. Once I click, it says chat history is saved. Now let's log out and log in again to test the same. Let's see, temp4 is the username and the password is type, and here we go. This is our chat. So now if at all I click the clear history, and it becomes empty. Let's just see what services are running. kubectl get all. So as you can see, we have a Flask app which is running, and Mineo service, and we have a service, Flask app service, which is using load balancer, and this is the external IP generated with which we are hosting the app. So now here we can see the log. So these are the requests processed when we are trying to give the demo. So this is the log, and here we can debug whatever the issues we get in the app. Now let's go back to slides. We successfully developed a scalable mood detection chatbot leveraging Flask for the API layer and GKE for deployment, ensuring efficient multi user handling and seamless API interactions. Looking ahead, we plan to upgrade from SQLite to scalable databases like PostgreSQL or Cloud SQL to accommodate larger data sets and higher traffic. Optimizing model inference with faster engines like TensorFlow Lite or ONNX will enhance response times. Additionally, we aim to refine the chatbot's user interface, making it more intuitive and engaging. These enhancements will further boost the system's performance and user experiences. Thank you.